Hi, welcome to Frank Vero Designs. Today we're doing episode 2 of Hardware Demystified, talking about memory, or RAM. The best way I can think of to describe how a computer works at a base level is if you've ever tried to do calculations for work using a calculator. Generally it's a three item process if you're doing really difficult calculations. You have your calculator, which really just does the math and spits numbers out at you. It does have a memory function, but you can only store one or maybe two values in it. Then you'll probably have a notebook. You'll have a couple of the key formulas you use a lot in here, and this is where you'll scribble down numbers you need to remember for a few steps later. And then you'll probably have, some textbooks or whatever with the really deep info that you might not need, but you might need once in a while, so it's there for reference. That, in a lot of ways, is how a computer works. Your CPU is the calculator. It does the math. And it does have a small amount of storage space called the cache, where it can really quickly, because it's actually on the chip, dump numbers that it needs to remember to do the next step in the calculation, but it can only hold a little bit. Normally cache is 16 megs, 32 megs, something like that. So it's pretty small. It can only hold a little bit of information. Next, you have your notebook, where you put the most vital information that you're using the most often. This is the memory in a computer. This is where you'll load up software you're currently using. You'll load up the files you're currently using so that it can quickly go and grab them. And then you'll also have some information on your hard drive, where it kind of surprises your computer that you actually needed to use this other function. So it needs to go look in the hard drive, find the actual little bit of info you need, and the way the computer works is it pulls that then into the RAM. So, obviously, how good your notebook is a little bit important to how quick you can actually do your job. So today we're going to talk about this notebook and the 4 things that really matter when it comes to how well it works. So today we're going to talk about how to get the best notebook for you. And that comes down to 4 things when it comes to memory. There's the speed of the memory, which is a combination of how quick it works and how quick it works. I'll explain. There's the capacity, so how big your notebook is, how much information you can actually stuff in that notebook at a time. There's how many slots, so I guess kind of how many pages, but not really. Okay, this is falling apart. So we're going to talk about capacity, how big your notebook is, speed, how fast your notebook is, how many RAM slots you can fit, and how many you're currently using, which is, I guess, a factor in how fast your notebook is, but also if you can add additional notebooks later. And then the generation, because there's a new generation of RAM coming out soon. You don't super need to worry about it yet, but in a couple years when people might still watch this video, it might really matter. So I'll briefly touch on that too. Let's get into it. So this is actually a stick of memory, or RAM. One of the easiest things to look at first is the capacity, how big it is. So this can range from, nowadays, about 4 gigs of memory you'll see in some computers. Normally you won't see 2 anymore. but it goes up in relatively regular intervals unless you're doing a really weird high-end system that has different numbers of slots for these to fit into. But generally it goes 2, 4, 8, 16, 32, 64, 128. But most likely 2 is going to be too small at this point. 4 is good for light entry, not entry, but lightweight computing. If you're doing mostly things like Office, Word, that type of things, you might be able to get away with 4 gigs of RAM. 8 gigs of RAM is a little more common. You'll see that in entry-level gaming machines. You'll see that in entry-level productivity stuff. It can handle a bit more multitasking in programs that are a little heavier. 16 is the sweet spot for RAM for gaming. Most games want at most 16. And for productivity, for most kind of mid-level productivity software, 16 will do great for you. For Photoshop, even for video editing software, for the most part, you'll be fine. Then if you do 32 gigs of RAM, that's when you're getting into a little bit more performance level. There's only a couple games like Microsoft Flight Simulator currently that say they actually want up to 32 gigs of RAM. And that's going to be for really larger files in those productivity software. So bigger video editing, bigger Photoshop files, medium-sized 3D modeling stuff. And really 64, 128 is when you're getting into really high-end computers or very specialty computers for running simulations or servers or things like that. So for most people, the sweet spot is going to be that 8 to 16 range, occasionally 32. One thing to notice too with how the capacity is listed is it might actually be listed as 8 times 2. So that means this is 2 8-gig sticks of RAM. This, you can see, actually says that it's from a 4-gig pack. So it's still 16 gigs total, but 4 of these came in one package instead of 2 in this package. And I'll explain why that might be better or worse later. But that's the key thing to look for. A lot of times it won't just say this is 16 gigs because you'll buy them actually in pairs for a reason, again, I will get into when we talk about DIMM slots. Okay, so the speed of the RAM comes down to 2 things. The first number and the most obvious number that people list is the clock speed. That's listed in megahertz or MHz. And that can range nowadays with the current RAM we have, which is DDR4. That ranges from about 2000, I think it's 2133, up to, I mean, you can get sticks that go up to like 5000 megahertz. But realistically, high 3000s is about the highest you see. And that's limited both by your processor and by your motherboard. So this is one of the places where you need to kind of pay attention if you're building a computer yourself to your motherboard and your processor and what they say they can do. For instance, Intel technically considers it overclocking to enable what's called the XMP profile, which is basically a built-in overclock of your memory. So you can only enable XMP on Intel CPUs with certain motherboards and maybe even with certain processors. Whereas AMD is fine with you doing it whenever you want. They don't care. It doesn't void your warranty. Every motherboard can do it. Every processor can do it. You can enable XMP and go up to, for 3rd and 5th generation processors, I think 3600 is about the sweet spot. Once you get to 3800, things get dicey. But basically, the clock cycle is how often it does something. So it sends a signal 32,000 times a second, or 32,000 mega, so 32,000 or something. Then the other part of your speed is actually the timings, which if you look at a RAM stick, it'll say that this is DDR, this is old, this is DDR3. DDR3 1600, and then it'll say CL 99924, which you won't see with faster RAM. You'll see more like 16, 16, 16 something. And those numbers are each for a different type of thing the RAM needs to do and how many of those clock cycles it takes to do it. So 16 means that of those 36,000 things it does each second, it takes 16 of them to write to the stick of RAM or to find something on the stick of RAM, whatever the case may be. So your overall speed is really a combination of that. You want a higher clock speed number and a lower timings number. Generally, the timings, if you're buying decent, reputable RAM, is going to be pretty close. They're all going to be pretty similar for similar clock speeds. So the clock speed is the more important thing to pay attention to. But the timings does definitely play into it. And for timings, down in the description, I'll put a link to, there's a video from a channel called Gamers Nexus that goes really in depth in explaining actually how those timing numbers work and what they mean. And that is above my head. So by all means, go there. It's an awesome channel, really in depth, great information. Highly recommend it. But that's the main things you need to know are the speed you want. Higher clock speed, lower timings means faster, which means it can, again, that's how quickly you can write in your notebook or look at numbers in your notebook and type them into your calculator, I guess. Yeah. So the next factor is the number of slots you have on your system. They're called DIMM slots in desktops. In laptops, they're called SO-DIMM because the RAM sticks are shaped differently. In laptops, they're only like that long. So there's two main things to think about when you're looking at how many DIMM slots you have and how many sticks of RAM you have. The first one being, ideally you want for most motherboards, unless you're doing really high-end enthusiast stuff with weird numbers of RAM slots like I mentioned earlier, for most you want an even number of RAM sticks, and you want them all to match. If they all match, they'll all run at the same performance level. If they don't match, they'll all clock down to the worst RAM you have, basically. But if you have even numbers of matching sticks, then your computer runs in dual channel, which means that it can actually basically, instead of having one little pipeline of information going back and forth between your RAM and your CPU, you have two. And that's true whether you have 2 sticks of RAM or 4 sticks, but it doubles your channels, which makes your RAM faster. So ideally, you do want dual channel. You want an even number of sticks, not just one. However, you may also want to make sure you have some open slots. So for desktops, really small form factor motherboards sometimes only have 2 DIMM slots, in which case you want to fill them both. And if you want to upgrade to get more memory later, you'll have to actually get rid of those 2 memory sticks, try and sell them on eBay or whatever, and then buy 2 new sticks of RAM. Whereas on larger form factor, or even like moderately small, just not super small, you'll have 4 sticks of RAM, 4 slots, which means that you can get 2 of these, pop them in, you'll run in dual channel, they'll be nice and quick, but you'll still have another 2 slots. So in a couple years, if you want, and you're deciding that 16 gigs of RAM maybe isn't quite enough for you, you want to jump up to 32, instead of throwing out those 2 8 gig sticks and buying 2 16 gig sticks, you can keep your 2 8 gig sticks, buy another 2 matching 8 gig sticks, and pop them in. Still runs dual channel, but your capacity is now higher. So in terms of your upgrade path, ideally you have some open slots, but you also want to have 2 slots used. So it's a little bit, when you're doing a laptop or a really small form factor, you have to balance those a little bit. For most computers, it just means you want to be careful and pay attention to whether it's a single 8 gig stick or 2 4 gig sticks, because you want the 2 4s, not the 1 8, which sounds a little weird, but. So, as I mentioned earlier, I think, this stick of RAM is DDR3. This is about 8 years old at this point, which is why I have it in my hand. I'm waving it around because it's from my old computer that's broken, and I'm pretty sure this stick of RAM is dead, so whatever. But that was DDR3, and that was DDR3 and 1600 megahertz. The last 2 computers I built, I used this, which is DDR4 RAM. So it's the next generation. It's the generation that, as of, Q1 2021, this is still what you can get. And this DDR4 is 3600 megahertz. The main thing you want to know, though, is they just finished creating the standard for DDR5, which is going to be the next generation. None of the current processors as of Q1 2021 can actually run DDR5, but I think Intel said their next generation, so presumably, I don't know if that's supposed to be fall of this year or spring of next year, will run DDR5. I would guess AMD's next generation will as well. And I don't know if those are going to end up being delayed because of all the shipping and supply issues that are currently happening. You're in the future. You might know better than me. But generation is an important thing to pay attention to. The way the slot works and where this little dent is actually different in each generation, so you can't put the wrong generation in. But it also means if you buy a brand new computer in 2 years that can use DDR5 RAM, it won't be able to buy DDR4, so you have to pay a little bit of attention to which one you're actually getting. So, what it comes down to is those 4 things. You want enough RAM capacity, so if you're doing easy low end, not low end, but easy low weight stuff, 4 gigs will be fine. If you're doing more complicated stuff, you might want to move up to 8, even more complicated, 16. 32 and up, I would say you're going to know if you need that much RAM. For most people, 16 is more than enough or perfect. For speed, higher clock speed is better. But remember that for AMD, that kind of maxes out at 36 or 3800. For Intel, that'll max out in the 2000s somewhere, unless you have an overclocking CPU and motherboard. Make sure it's the right generation. Right now, that doesn't... If you're buying a pre-built computer, it doesn't super matter because they're not going to put the wrong RAM in, and that's kind of all that matters at this point. And pay attention to whether it's 1 or 2 sticks and how many open slots you have, so you know if you're running dual channel or single channel. and what your upgrade path looks like. I know when I used to buy laptops more, one of the things I always looked for was computers that had like 2 sticks in and 2 open slots so that I'd be able to actually upgrade my RAM down the road. But those are the main things you want to look for when it comes to RAM. So go down, hit subscribe if you want to make sure you don't miss the next Hardware Demystified. I believe that's going to be on graphics cards, or my work from home builds. I believe the first one is going to be on a landscape architecture build. Send comments if you have jobs you'd like for me to do later in my work from home build series, or if you have questions about RAM because I glossed over something, or just a question about something I haven't covered yet so that I can make sure to cover it when I do that video. And like this video because it makes YouTube happy. Tell your friends if you think they could use this information. That would be awesome. And otherwise, yeah, stay safe out there.